In this session, we will introduce lean functional testing, also known as LeanFT. We will start with a short introduction of the product, describing its concepts and major capabilities, and then we'll see a live demonstration. So what is LeanFT? LeanFT is a lightweight but powerful functional test automation solution. One of the biggest challenges for software development today is meeting the business demands of speed and agility. Trying to meet these challenges has led to adoption of agile development methods. A key component of agile development is continuous integration and continuous testing, which needs to take place earlier in the development lifecycle. This is known as shifting left. LeanFT was designed specifically to address this shifting to the left by enabling continuous testing and continuous delivery, as we'll see throughout this session. LeanFT is targeted for technical automation engineers, dev testers, and developers that can use it to automate applications using standard development IDEs and modern programming languages, and integrate the automation into the DevOps process. So now let's see some of the highlights of LeanFT. LeanFT integrates with the standard development IDEs such as Visual Studio, Eclipse, and IntelliJ. It provides an SDK, which is an automation code library that is used in the IDE testing projects to automate scenarios in the application. It also provides plugins for each of the IDEs. The plugins extend the IDE with LeanFT's tools and capabilities that are used to create better tests, easily and efficiently. The LeanFT SDK is provided in 3 flavors: .NET, which is used to create the tests using C#, Java, and JavaScript. Therefore, you can automate your application while using the programming language which best fits to your needs. LeanFT can be used to automate a variety of applications created by different technologies. It enables automating both thick client applications like Java and .NET applications, and web and mobile applications. LeanFT is compatible with UFT. UFT concepts, like the concepts of test objects and descriptions, and tools, like the object spy and object repositories, were adopted by LeanFT. The services which are provided by the UFT API exist in LeanFT as well. Therefore, if you have knowledge with UFT, the transition to LeanFT will be natural. Moreover, a lot of the assets you created with UFT, like object repositories, can be leveraged when using LeanFT. Finally, LeanFT is integrating naturally into the DevOps ecosystem. In addition to leveraging the standard development IDEs, you can manage your test code in standard source control management systems, run LeanFT tests from Jenkins, leverage standard unit testing framework, and more. More on this later on in this session. We provide several functional test automation products. Let's see where each of these products, and specifically LeanFT, fit. Test automation involves several personas, each has its own characteristics. We can identify the subject matter experts and business analysts as people who are business experts, meaning they have the knowledge and familiarity with the business processes that should be addressed by the application under test. They can define what should be tested, but usually will either delegate the testing task itself or will be involved in the testing being done manually. We can also identify the persona of the test automation engineer, who is a technical engineer having the expertise of automating applications using tools like QTP or UFT. He will usually have a certain level of familiarity with the application under test and its scenarios, but he is not a business expert. Finally, we have the agile automation engineers and dev testers. These are highly technical people having advanced programming skills and a good knowledge of the development ecosystem. They automate the application continuously during its development cycle and run their tests through a continuous testing process using continuous integration tools like Jenkins. For the subject matter experts and business analysts, we provide BPT, business process testing, that can be used to define tests for the business processes using business components, and even enables to actually implement these components, either as manual components that can be later on automated by the automation engineers or as automated components using keywords. For the so-called classic automation engineer, HPE offers UFT, Unified Functional Testing, that provides a powerful IDE, including a lot of capabilities, which increases his productivity while automating the application. We also have the Agile Automation Engineer and the Dev Tester. They would like to automate their application using the standard development ecosystem and tools, for instance by using development IDEs, creating tests using modern programming languages, and integrate them into the DevOps process. LeanFT was designed specifically to address their needs, as we'll see during this session. As mentioned, LeanFT enables automating applications created with different technologies. You can use LeanFT to automate your web applications. LeanFT supports all of the standard browsers like Internet Explorer, Firefox, Chrome, and the Microsoft Edge browser. LeanFT keeps supporting the latest versions of these browsers while being released. As LeanFT is a cross-browser tool, you can automate a web application with a certain browser and run the same test on any of the supported browsers. Using LeanFT's seamless integration with Mobile Center, you can also use LeanFT to automate mobile applications, native, hybrid, and web applications. Automating mobile applications is supported on both iOS and Android devices. LeanFT can be used to automate also thick client applications like .NET applications, both WPF and WinForms, Java applications, standard window applications, and even SAP applications, both SAP GUI client and SAP UI5 applications. LeanFT also supports Insight technology, which enables an image-based object recognition. As a tool which was designed to support automation in agile projects and enable continuous integration and continuous testing, LeanFT is naturally integrating with the DevOps ecosystem and tools. LeanFT tests are created in standard development IDEs such as Visual Studio, Eclipse, and IntelliJ, while using standard and modern programming languages such as C#, Java, and JavaScript. LeanFT's SDK can be used to automate applications while using standard test-driven development and behavior-driven development frameworks such as NUnit, JUnit, TestNG, and Cucumber. The LeanFT IDE plugin even provides several IDE projects templates for these frameworks that can be used to easily create testing projects based on these frameworks. The source code of tests created with LeanFT can be managed while using standard source control management systems, such as Git and SVN, exactly as managing the application source itself. You can run your LeanFT tests from the common CI systems such as Jenkins. You can see the LeanFT test execution results in the CI system and can even easily configure it to present a link to the LeanFT HTML run report for each job build. As mentioned before, LeanFT enables automating applications created by all of the common technologies. Therefore, if you have different applications created with different technologies, you can use one tool, LeanFT, to automate all of these applications. Finally, you can integrate LeanFT with common test management systems. LeanFT provides a built-in integration with HPE's Application Lifecycle Management. Now that we have a basic understanding of what is LeanFT, let's review its main core features. The core of LeanFT is its SDK. The SDK is a comprehensive and user-friendly automation code library which is used in the test script to define the interaction of the test with the application. Each type of application object in each supported technology has its own types within the SDK and provide all the API which is needed to identify objects of that type and manipulate them. The SDK is available in .NET, Java, and JavaScript flavors. As mentioned before, LeanFT provides plugins for each of the supported IDEs that extends that IDE with several LeanFT tools and capabilities. One of the most powerful tools, which is part of the plugin, is the Object Identification Center. The Object Identification Center is used to inspect or spy objects in the application under test, getting their properties and building unique identifications for these objects to be used in the test script. The tool even provides recommendations for a unique identification. Using the tool, it is possible also to customize the object identifications and test them. The LeanFT IDE plugin provides the ability to model the application objects and application models. The application objects are modeled as test objects and application models by using a rich graphical user interface that is embedded in the IDE itself. Test objects of the application model can be easily accessed from the test source and used to manipulate the corresponding objects in the application. Using application models enables a better separation between the test logic to the object's identifications and results in a cleaner and more maintainable test scripts. When objects in the application change, there is no need to update the test scripts that are manipulating them. Instead, it is only required to update the relevant test objects in the application model once. and then all the tests that use them will continue to run successfully without modifications. Lastly, when running LeanFT tests, LeanFT automatically creates a rich HTML run report. The report can be opened in standard browsers and can be linked easily, for instance, from Jenkins. It presents the entire execution flow, including all of the steps, and for each, information about the data that was used in the step, a snapshot of the application while running it, and more. In case of execution failures, the report provides useful details of what was the failure reason and where exactly in the code it happened. Before moving to the live LeanFT demo, let's see how LeanFT can be installed. There are two options for installing LeanFT. The first option is to install LeanFT through the UFT 12.50 installation. LeanFT is included in UFT 12.50, and if you would like to have both products installed on the same machine, you should simply select the LeanFT item during the installation. Another option is to install LeanFT as a standalone product. It is possible to download a standalone LeanFT package, which includes only LeanFT, and install it. When installing LeanFT, you can select one of two installation modes. The first option is installing the LeanFT runtime engine only, which is useful when you have your LeanFT tests ready and deployed on the lab. In this case, you should use this option, which will include only the LeanFT components which are required for execution. The second option is to install the full LeanFT package, which in addition to its runtime engine will also enable you to install the LeanFT IDE plugins for IDEs which are installed in your machine. So now that we have some idea of what is LeanFT, what are its main features, and how to install it, we are ready to actually see it in action. For the rest of this session, we will have a live demonstration of LeanFT. We will see how to use LeanFT to automate a certain scenario in a demo web application. LeanFT can be used with several development IDEs, such as Visual Studio, Eclipse, and IntelliJ. In this demo, we will use Eclipse. Using LeanFT with other IDEs is similar. Let's open Eclipse. When opening Eclipse or any other IDE with the LeanFT plugin, the LeanFT runtime engine is automatically launched. The runtime engine is responsible for any interaction with the application under test. Once Eclipse opens, we can see the LeanFT menu. This menu is part of the LeanFT IDE plugin and includes several options and tools, some of which we will cover during this demo. The demo application simulates a website which enables product purchases. For example, we can purchase tablets, laptops, speakers, and so on. We will automate the scenario of purchasing a tablet. Before creating our test, let's first review the scenario. We will click the tablet category and filter the list of tablets by the memory type. Then we will click the tablet's price to get more information about the tablet. Add the tablet to the cart and check out. We will add a verification for the total price. And finally, we'll provide some details in the user login form and click Login. To automate this scenario, we should first create a testing project. The LeanFT SDK can be used in many project types. However, it is recommended to create LeanFT tests in the context of standard unit testing frameworks projects. LeanFT's IDE plugin provides project templates for standard testing frameworks. Let's create a LeanFT JUnit-based testing project while using the LeanFT JUnit project template. The LeanFT folder includes several items, one of which is the LeanFT JUnit project template, which enables us to create a JUnit project and automate our test using the LeanFT SDK. We select it and click Next. Then we give a name to our project, as well as a package name, and click Finish. We can see that a standard JUnit class was created. We will use it later on to automate our scenario. The most important method in this class is the test method, which is annotated with a test annotation. This is a JUnit annotation which designates the method as a test method. Since we created our project based on a LeanFT project template, the LeanFT SDK is automatically referenced to our project. Now let's start automating our scenario. We will start by providing a more meaningful name to the test method. LeanFT enables automating applications of several technologies like web, .NET, Java, and more. Every type of technology has its own package inside the LeanFT SDK. Since we are automating a scenario in a web application, we should use the LeanFT web package. Let's import it. Now we will write the code to launch the browser. We use LeanFT's Browser Factory class, which enables to either launch a new browser or to attach to an existing browser. We will select the launch operation to launch a new browser. We should provide a browser type which can be any of the browsers supported by LeanFT: Chrome, Edge, Firefox, or IE. Let's select Chrome. As LeanFT is a cross-browser solution, we can later on change this to another browser, or parameterize our test to get the browser as a parameter. To navigate to the application URL, we will use the browser's object navigate method. Then, as mentioned before, we want to write the code which will click on the tablet category. For this, we should first know how to identify this object in the application. LeanFT provides a very powerful tool called the Object Identification Center, which can be used to create identifications for objects. The tool can be opened directly from the IDE using the Object Identification Center item in the LeanFT menu. Let's open it. We will start spying our object by clicking the Start Spying button and hover over the object. We can see that the object was identified by LeanFT as a web element. And we can also see a long list of object properties, which will help us create a unique identification for this object and use it in our script. The Object Identification Center also provides CSS and XPath expressions that can be used if needed to identify objects. We can see that near some of the properties, and also near some of the objects, there is a star icon. This is a LeanFT's recommendation for a unique identification of the spied object. Using start objects and properties to identify the spied object guarantees a unique identification of this object. In other words, there will be one and only one corresponding object in the current page of the application. We can test this identification directly from the Object Identification Center by clicking the Highlight button. Now that we have a recommendation for a unique identification of the object, we can go back to our script and write the code to locate our object based on this recommendation using LeanFT's SDK. Alternatively, we can use the Generate Code to Clipboard button to create this code automatically. When clicking this button, an identification code for this object is being generated in Java. The identification is based on the recommended properties. We can then simply paste this code in our script. When using LeanFT in Visual Studio, the Generate Code to Clipboard capability generates the code in C#. In addition, it is possible to configure the Object Identification Center to generate JavaScript code, which is useful when creating tests using LeanFT's JavaScript SDK. The browser's describe method returns a test object. A test object corresponds to an actual object in the application and enables us to manipulate it. We can select one of the methods provided by the test object's API in order to activate or query the corresponding object in the application. We will select the click method to perform a click operation on our object. Let's continue to automate our scenario. As mentioned before, we would now like to write the code for filtering the list of tablets by the memory type. To do this, we will first write the code to expand the memory category by clicking it. We will spy the memory element by clicking the Start Spying button and hover over the element. We see that LeanFT provides a recommendation for a unique identification of the object. We can highlight the object to verify the identification uniqueness, and again, either manually write the code in our script based on the recommendation, or generate it automatically by clicking the Generate Code to Clipboard button. Let's generate the code and paste it in our script. Since we want to click on this element, we will again use the click method. Then we would like to click the second checkbox, for example, so we will spy on it. We can see that it was indeed identified by LeanFT as a web checkbox, and we can see all of its properties as well as identification recommendation. But let's say that we want to provide our own identification for this object, and not use the identification recommended by LeanFT. For example, we see that this object has a class name property, and we want to use it to identify the object. This can be done by switching the Object Identification Center to its Edit view, which enables customizing the identification. The Edit view is very similar to the view that we have seen, but in this view, next to each object and property, there is a checkbox, so we can actually select which property shall be used to identify the object. We can also change property values if needed. Let's select the class name property. To test whether our identification is unique or not, we will click the highlight button. As we can see, there are several highlighted checkboxes, which means that using the class name alone doesn't provide us with a unique identification. We will refine our identification by adding more properties like the isVisible property, which will instruct LeanFT to locate only visible checkboxes. We will also add the index property to instruct LeanFT to locate a specific checkbox out of all of the checkboxes which match the marked properties. Then we will highlight again to validate our identification. We can see that we now have the unique identification. Now, as before, we can either manually write the code based on the properties used for identification, or simply use Generate Code to Clipboard and paste it in the script. The LeanFT API provides specific methods for each type of object. In our case, since we are automating a checkbox, we can use the set method, which is available for test objects of checkbox type. Let's go back to the application. We see that after filtering the list, we have only one tablet. First, we would like to store its price, because later on we will want to validate the total price of this purchase. For this, we should first identify the price object. We will spy on this object, use the class name property for the identification, and highlight it. We see that there is only one element in the application that matches this description, because we only have one tablet. Since the application simulates an online store, in future runs of our tests there might be more than one tablet here. So we'll want to write a code which is more dynamic and automate the first tablet presented after applying the filter. Let's copy the code and paste it in our script. But now, instead of using the describe method, which expects to have only one element in the application that matches the given properties, we'll use the findChildren method. The rest of the syntax is exactly the same. The findChildren method returns a collection of objects based on the given object description. We would like to get to the first one, so we will use an index to fetch the first item in the collection. Then we can store it in a test object variable. We will now define a new variable named tablet price, which will store the price of the tablet. We will get the actual price of the tablet by using the getInnerText method of the test object. We will use this price later on in our script. We also want to click the tablet's price link to get more details about the tablet. For this, we can simply use the test object we created and call its click method. Now we would like to automate the operation of clicking the Add to Cart button. So again, we will use the Spy button to start spying. In this case, we do not want to customize the identification, so we can switch to the Simple mode. Then we copy the code to the clipboard, paste it in the script, and use the click method. We will do the same for the Checkout button. As mentioned before, we would like now to validate that the total price of the purchase is what we expect, which means exactly the same as the price of the tablet. For this, we would like to fetch the total purchase price from the application. We will first spy on the price element. If we take a look at the recommended identification properties, we can see that one of them, the inner text property, has a fixed value for the price. Since the price can be changed, relying on its current value for identifying the object is not a very good idea. Therefore, we will customize the identification to be more dynamic. We can do it by switching to the Edit mode, selecting the 3 recommended properties, but instead of using a fixed value for the inner text property, we will define the value as a regular expression, which represents any text which starts with $. We provide the regular expression and mark the property value to be treated as a regular expression by clicking the star button. We can test the identification by clicking the highlight button. Now we can copy the code to the clipboard and paste it in the script. As we can see, the generated code indeed uses a regular expression as the value of the inner text property. We'll get the actual price by using the test object's getEnterText method. We will store it in a variable named total price. Now that we have the tablet price and the total price, we can make a verification to compare these prices, making sure that indeed the total price of the purchase is as we expect. While verifications can also be done using the testing framework's assert class, LeanFT provides its own class for verifications, the verify class, which is part of the LeanFT SDK. By providing it with the expected value, which is the tablet price that we fetched earlier, and the actual value, which is the total price that we just stored. We can also provide a name for the verification to be included in the LeanFT report. Let's go back to the application. We would like to finalize our script by including the code which fills the username, password, and email fields, and click the Login button. But this time, instead of writing the identification code for these objects inside our script, we will model them as test objects in the LeanFT application model. Then, in the script, we will use the application model's test objects to manipulate the corresponding objects in the application. Using application models enables us to separate between the object identification code to the actual application logic to be automated. The result is a cleaner script, which is more readable. In addition, tests which activate objects that are modeled in application models do not need to be modified if the objects in the application change. In such a case, all that is needed to be done is updating the test objects in the application model to be consistent with the objects in the application. The tests which refer to these application model objects will keep running without modifications. Let's see how we can model these objects in the application model. We first create an application model in our project. We do it by right-clicking the project, selecting New, and under Other, selecting the LeanFT application model item. We provide it with a package name and application model name. The name we provide for the application model will be used later on when referring to objects of the application model from our script. Let's click Finish. The Application Model Editor opens in a new tab in the IDE. The Application Model Editor enables us to model our objects. Let's see how to do it. We open the Object Identification Center, this time not from the LeanFT main menu, but rather directly from the Application Model Editor. Then, as we want to model the username field, we spy on it. We can see that it was identified as an edit field and all of its properties, But this time, instead of clicking the Generate Code to Clipboard button, we will add the object into the application model by clicking the Add Object to Application Model button. If we go back to the Application Model Editor, we see that a test object for the user name field was added under an object which represents the page, and that both of these objects have properties that are used to identify them. We can also customize the identification of these objects by selecting the All view, in which all the properties of the objects will be presented, and the object identifications can be customized if needed. Now let's do the same for the other objects, which are the password and email fields, as well as for the login button. But instead of spying each of these objects separately, we will see how to add all of these objects into the application model at once. We do this by selecting a container of these objects, which in this case is the page object, and then selecting the Learn Child Objects option. LeanFT scans the entire page and presents all of the objects grouped by their type. For example, we can see here groups of images, edit fields, buttons, and so on. As the password and email fields are edit fields, we can find them under the Edit Field group. We can highlight objects to verify that they represent the correct objects in the application. Now we select the password and email fields to be added to the application model. We will do the same for the Login button. We can see a summary of all the selected objects by clicking the Selected view. We can now add all of these objects to our application model by clicking the Add button. If we go back to the Application Model Editor, we can see all the objects that we have added. Each of these objects has a logical name that we can change, and also a code name, which will be used to access these objects from our script. We can use the names provided by LeanFT or change them if needed. We will now save the application model so we can use its objects from our script. Behind the scenes, LeanFT generates a class based on the application model and its objects. We can see the generated class under the App Model folder. The name of the class is Demo App Model, which is the name we provided for the application model when we created it. Now let's see how we can use the application model objects in our script. We will first create an instance of the Demo App Model class and provide it with an argument, which is the application model context. In our case, the context is the browser object that we created at the beginning of our script. The browser object itself is not modeled in the application model, so we can reuse the same application model for different browsers, while providing it with the relevant browser object each time. Now that we have the app model object, we can use it to access the test objects inside the application model. If we go back to the application model interface, we can see that the page object is the codename of Advantage Shopping Page, and that the username object has the codename of username. Let's see how we use these codenames in order to access the username object. The API of the app model variable includes a method named Advantage Shopping Page, which was generated dynamically based on the codename that we provided for the page object in the application model. We see that the page object API includes a method named username, which is the codename of the username object. So accessing the username object in the application model is done simply by using the generated methods of the application model class. Once we access the username object, we can use its API to set the username field with the value. We will use the setValue method, which is one of the methods provided by the API of Edit Field Test Objects. We would like to do the same for other objects that we added to the application model, like the password and email fields, and also for the login button. We can either write the required code manually, as we did for the username object, or use a shortcut. Let's see how to use this shortcut for the password object. We right-click the password object in the application model editor, select the Generate Code to Clipboard option from the menu, and paste it in our script. Then we can use the object's API to set a value in the password field. LeanFT provides a special API that can be used to send encoded data to the application. This is very useful when, for instance, sending passwords in case we do not want to include the password itself in our script. Encoding the password can be done by using one of the tools provided by LeanFT, the Password Encoder tool. We will type the actual password in the tool and click the Generate button to encode the password. Now we click the Copy button and use it in our script. Instead of using a setValue method, we will use the setSecure method, which enables us to provide encoded values. All we have to do now is paste the encoded password in the script. We will use the application model also to provide a value in the email field and to click the Login button. If we take a look at the code we created while using the application model and compare it with the code that we created before, we can see a noticeable difference. When using the application model, the code focuses on the scenario to be automated and doesn't deal with identifications of the objects themselves. Therefore, application models enable us to separate between the logic of the scenario we are automating and the identification of the objects. Our test is ready, and now we would like to run it. But before we run it, let's see how we can configure LeanFT to take snapshots for steps being performed while running the test. This can be done by opening the LeanFT properties file, uncommenting the snapshot level option, and changing it from off to on error or to all. Now let's run our test directly from Eclipse. We can do it by clicking the Run button. The automated flow is being executed. As we can see, the test was executed successfully. As mentioned, while running LeanFT tests, LeanFT automatically generates a run report. The run report is a standard HTML file that can be opened with any browser. The report can be easily opened from the LeanFT menu in the IDE by selecting the View Last Run Results option. Let's open the report. The report opens in the default browser, and we can see the entire execution flow, which includes all the steps that have been performed during the run. We can see the operation of each step, as well as the values or parameters that were passed to the operation. For each step, we can also see information about the identification of the object that was activated by that step. Since we configured the report to take snapshots, they are included in the details of each step, while the relevant object is highlighted. The LeanFT run report also captures a lot of useful information about the environment on which the test is executed. For example, we can see the total memory of the machine on which the test was run, its operating system, and so on. Finally, the LeanFT report is highly customizable. LeanFT's SDK provides a class-named reporter, which can be used to include manual steps into the report steps flow, and additional information about the environment and more. For more information about LeanFT, visit the LeanFT webpage and the LeanFT Help Center.